Okay. Thank you for the introduction. So now I'm start to present the grounded language acquisition paper. I'm going to share my screen. Right. Can you see my screen?
Yes.
Okay. Um, so now, okay, I'm going to present the paper published in 2024 by Von et al. Grounded language acquisition through eyes and ears of a single child. So I am pretty novice to machine learning. So if you find any confused or you want to correct me something, just feel free to point it out. Okay. So before starting, I want to say clarify what is the grounded language. Language is grounded in experience. It is not just an abstract or symbolic thing. So they are grounded in our real world context. Okay. And our interaction with the environment. So people need to interact physically with their word and so that they can grasp the essence or meaning of the word. For example, like the red and the heavy and the above this kind of word. So this paper essentially discuss two modality, visual and then auditory, that help children or infants to grasp the meaning of the word. And okay, what is the major research question? The major risk question is that children learn the word from around 6 to 9 months old, right? So here, the learning I means here is that they connect spoken word to their visual counterpart, right? So the author asks, how do children get started on the word learning? What kind of learning mechanism and the representational commitment are needed for the word learning? The motivation of this study is that there is a huge gap in how AI system like GPT-4 and the children learn language. So the best AI system now trained on the test with the word count in trillions. That's very huge. This kind of data, it will take a child about many years to match the amount this kind of data. So due to this kind of data gap, many researchers have been skeptical about what recent AI advance can tell us about human language acquisition. So now, I will skip something about the previous account of the curtain study. I will directly say this present study aimed to test from the most simplest one, asking would the simple account driven by associated learning with feature-based representation, would that sufficient for this kind of learning? It investigate to what degree a child or infant can learn from vision language association. That is the learnability of word reference mapping. Okay, so the most interesting thing of this paper is that they test this question in um, a very novel way. So they train a neural network instead of using data from internet database. They train these neural networks by only the input that a child receive. So let's see how the data was collected. So this is the head-mounted camera that collecting data. And then on the top of the screen, that's the video frame sampled from the real data. So they applied constructive learning model to child viewed data, which is this video. We call it child view for constructive learning, contrastive learning model, CVCL. The associative learning input will be this kind of longitudinal head-mounted camera recording. I think it is around 61 hours. So this machine learning model will learn by the temporal co-occurrence between visual stimuli and then auditory stimuli in an self-supervised manner. To know that this kind of self-supervised is a kind of unsupervised learning. So for example, if there is a butterfly in visual field, in the video recording, while the model also hear the butterfly at the meantime, so they will count it as a positive learn. Okay, so the result showing that after training, they got three main finding from this kind of training model. So first, they found that the model occur word referent mapping from 10 to hundreds of example. That's in short. Okay. So secondly, they found that the model can generalize zero shot to new visual, zero shot classification to new visual data set. That means that this kind of model is able to recognize and classify objects that have never been seen during the training. Okay, this is zero shot classification. So thirdly, they found that the model can achieve some degree of cross-modal alignment. In this case, is visual and the visual and the language alignment. So to conclude that the study aimed to find a minimal set of ingredients to allow machine learning model to get to a childlike language learning process. The performance of one-child view, uh, or let's say CVCL, shows that from one child first-person visual and auditory experience, representation learning and associative cross-situational mechanism are kind of sufficient to occur word referent mapping. And also then the thing that was difficult to understand in this case is that I have a little bit difficult to understand what is linear probe and then what is role in the context of this paper, and then what does frozen pre-training vision encoder means in this paper. And then the thing I want to discuss during the qualia structure is that in this data, the training data set, which is the recording, consists of this kind of first-person video recording, cover both visual and auditory modality. Then after training, the model demonstrate a certain level of childlike learning ability. Then, however, we know that human learning is a combination of passive information input and active exploration using their multiple modality. For example, infant climb everywhere to explore the surrounding environment. So unlike a child's active and embodied experience, this model, CVCL, lack this kind of sense like taste and smell, smell, yes, this kind of smell and touch. And learn in passive manner, which is only take information input rather than actively explore the environment. So if we were able to integrate a machine learning model into a robot, enable it to actively explore the world rather than merely accepting information passively, it might be more promising in developing stronger language learning ability. And to follow up this question, there is a philosophical question that asks, if a person with a congenital blindness, then he regained vision, would they be able to visually recognize the object that have previously learned through touch? So imagine a situation that I am blind until 20 years old, but before that, I have a girlfriend and I recognize my girlfriend through touch. But after that, when I regain my vision, can I identify my girlfriend? So some research has investigated this kind of question. Um, and the evidence suggests that initially the answer is no, no. However, this cross-modal mapping developed very, very rapidly, just in 2 or 3 days. So I guess that once this person regain their sight, they actively explore the world and quickly link their visual representation to their previous prior tactical knowledge gained by touch. So they this enable them to achieve cross-model alignment. So I am curious if I, we could simulate this process using a robot with machine learning algorithm and multiple sensor. This is still a very tentative idea, so I'm currently researching it further. So that's all my presentation. Thank you.
Okay, thank you very
Thank you.
much.
And next part is a Q&A. Yes, do you have any question or comment? And then, or for my question, the difficult part I have to understand. If you have any insight, please feel free to say that.
So, for my understanding, the linear probe model was, discussed as a kind of ideal model to, achieve some kind of word referent mappings. So, without considering some kind of ecological validity of data or something. So it is a kind of very straightforward way to achieve or to, engineering some word referent mappings. So it is kind of our upper
Really?
bound of the model. And in order to compare the CVCL's performance and the more kind of ideal model or something. Yeah.
Okay. And what is the difference between this kind of linear probe model and the clip? Because I know the clip is developed by OpenAI and it also counts as a upper limit of this kind of model.
So I'm not sure about the clip, but so one of the differences is that I think the clip so in the case of the
Excuse me.
clip, okay.
Yeah. As I read their paper of OpenAI, the clip is basically is based on the contrastive learning, and when I read this paper, I think the idea they are very different. Oh no, I'm sorry, they are very similar. It means that the clip they use the image net, and they also have data like the multi-model data, the data from the text and the image, and then they use contrastive learning. Here they also use to encode the first encode for the first encoder for the image, and the second is for the text, and then they use the contrastive loss to combine. And I think the clip is totally similar to the CVCR here. The difference is just the data set.
Yeah, exactly.
Oh, yeah, okay.
And so, for my understanding, the difference between the clip and the linear probe is like, so in the case of clip, so the visual data and auditory or linguistic data is given together. But in the case of linear probe, so the visual part is pre-trained, and the mapping from the some kind of visual to linguistic is added additionally. And
Okay.
so I think that's the difference. So and that is the very important part for this paper, because they put emphasis on the relationship between the different modalities, so or alignment between the different modalities representation space or something. Yep.
Ah,
I get it.
that makes more sense. Thank you. Thank you.
Okay, so this model they add the words, the utterance during the training.
Chinese.
You means that the CVCR they have different training strategy that, with the clip. They did.
No, I'm not sure, but so So for my understanding, I agree with what you say. So it's in that, you know, the only difference is the data given to the model or something. Yeah. So
I see.
The clip is trained by those pair of description of photo and this description, and then the amount
yeah.
is huge, right? The data is retrieved from the internet, but the CVCL, the data is only from first person view of video. Yeah, I agree with this.
Yeah, so can I make a comment? So what I found interesting in this paper is that, you know, the alignment between the visual, you know, concept space and the linguistic or word space. So, and I think that is the reason why Oizumi-san chose this paper. So because he is also, or his team is also interested in the, you know, the alignment between the some kind of color space and the, you know, the link the word space or color namespace or something in the link in the large language model. So and yeah, so and maybe some kind of, you know, so in this paper they evaluate the distance between the, you know, different concepts and, you know, or the distance between the two spaces. But maybe we can also evaluate some kind of structural or, you know, more topological similarities between those two spaces in terms of some kind of functors or something.
I have used Oizumi-san's toolbox optimize what is that GWOT algorithm to align my emotion experience between normal people and those for example alexithymia. This kind of people have difficulty in telling their experience. So some scientists assume that cannot tell emotion experience is indicating that they don't have experience, but this is not the case through Oizumi-san's toolbox. From the result, we see that they also have emotional experience, but the structure is different, so it cannot be explained or tell by some certain language. So that is some the finding. And I know that you are working on category theory. So two different what is that category or a field of modality, how to find the mapping between these two.
Yeah, so first of all, I'm not a mathematician. I'm relative, I'm, you know, relatively new to category theory, but, you know, so yeah, and so there are many, you know, concepts or mathematical tool to evaluate the difference and the similarity between two different categories. So, and there is a, you know, grade. So there is a nuanced and graded, you know, discrimination in that kind of, you know, the similarity and discrimination. So similarity and difference. And so and the most strong the strongest similarity is a kind of, you know, categorical identity, which means some kind of one-to-one mapping. But that kind of situation is very rare, and the more weak one is like, you know, the existence of adjunction. So which basically means that so if you go from one category to another category and go back to the original category, there can be some kind of, you know, discrepancy from the starting point, but that kind of discrepancy is very structured. So, and that kind of, you know, idea is can be, you know, discussed in terms of adjunction. And the more weak one is like, you know, the existence of functor, because which means that some kind of so mapping from one category to another category is structure preserving or something. So my answer is like, you know, there are various notion and there are graded notion of similarity that can category theory offer you to evaluate or conceptualize the similarity between two categories or something. Yeah.
Mm. Thank you. Thank you for clarification.
The comparing the structure, currently I just use the topographical similarity sim. Yeah, because my research is about the immersion language, and I want to compare the immersion language from agent 1 and agent 2. So I just compare the space of the message created by agent by two agent, and the similarity here is calculated by the top sim. Yeah, I just know that uh, measurement.
Because I noticed that category theory, and then also you are also working on some kind of mathematical optimization that I'm not very familiar with. I'm wondering if we can apply such kind of category theory to explain how machine learning model do this kind of cross-model alignment. So, and then it could also maybe can explain how human achieve this goal by by analyzing this kind of model.
I remember in your slide, you recommend that you think about expansion of this paper by because you said that the limitation of this paper is just the vision and the data is limited. And I
Yes.
think if you can expand it with more data, and you also can use the adaptive learning because you can consider it as a multimodal
Multimodal.
multimodal data. Yes, the multimodal data, the data with, for example, you also use the encoder, but the two encoder, but the first encoder will encode the image and the vision and the sound. The other encoder for the smell or something like that, and you can combine the contrastive here. That's what I think.
Yes. Yes, exactly. Yeah, that's also an interesting idea. But yeah, at the present, I don't know how to do it. Maybe in future, maybe after the meeting, I can do some research. We can further discuss during the quality structure meeting. Any more comment or question?
So can I say a bit about the multimodality?
Yes.
So yeah, so what I found interesting in this paper is their emphasis. So as I said, their emphasis on the cross model alignment or cross model or cross model mappings between the different modalities. And this is very similar to the category theoretic way of thinking, contrasted with the set theoretic way of thinking. So in the set theoretic way of thinking, so and we can connect them one-to-one by one-to-one mapping or something, but category theoretic way of thinking is like the two objects. We don't need to fully understand the two objects independently, and but their relationship is more has more priority than the two distinctive two independent objects or something. And also we tend to think that single modality is prior to the multimodality, but we can change that kind of way of thinking to the opposite one. So the multimodality comes first, and the those specific independent modalities come second or something. Yeah. And that's all.
Oh, can you explain a little bit more about why the prior of single modality and then multimodality? What do you mean by
Yes,
prior?
yeah. So this is just a kind of, this is just kind of idea, but but our experience is always multimodal, and
Uh,
this is always also true of, or maybe more true of the infants experiments. So and and maybe in the later developmental stage, those experience can be divided, or yeah, into more distinctively different modality or experiences or something. So
I see.
but this is just an idea, but you know what I want to say is that we tend to think that the single modality comes first, but maybe we can also think that, yeah, multimodality comes first, and and those each modal and those single modalities come second, or or kind of secondary thing or something. That's all.
Yeah, I get your point maybe. For example, this is a five modality of a infant, and then with their development, they start to like that.
Yeah, maybe,
Become
but
more distinct?
yeah, so yeah, so my image is like, baby, so infant's experience is more abstract, or
Integrated.
more amorph thing, and in the later stage of development, they deviate into some kind of more distinct experiences that is that corresponds to different modalities or something. So but yeah, but that's just a hypothesis. So, yeah.
Yeah, that's very interesting. Thank you.
I think it makes sense because
Mhm.
children they also develop the sense step by step.
Mhm.
So the multimodal is just the first one to be made. For example, the division will be the prior, and then to the second information, and then the third, and then the next one. So
Mhm.
we can so consider this idea.
Mhm. Thank you.
Yep. Okay, so now the time is 30 minutes. Let's jump to the second paper.